Hi students, my name is Ketan. I am going to cover GATE 2022 programming language questions in this session. Let us see the first question that have been asked, which for 1 mark. There were total 3 questions, out of which one is for 1 mark and other 2 are for 2 marks. So total, if we calculate, it is 5 marks of weightage on the programming language. What is printed by the following ANSI C program? Hash include int main, int x is equal to 1, some program is given, alright. The question is very straightforward, what is the output? Let's just have a look at the options. These are the options provided, alright. So let's solve this question. Int x is equal to 1, so I am going to take a variable x, value is 1. There is an array z. How many elements we have? We have 2 elements, alright, 10 and 11. Whenever we declare an array, the name of the array itself is a constant pointer. Don't forget that ever. So, z is the name of the pointer, and what it holds? It holds the address of the first element of the array. Let us take it is 500. So, it will be 500 and integer size is not given, not a problem. You can simply take 502, 2 bytes of integer, and 500 will be stored as the value of constant pointer z. Alright, that's our representation in memory. Let's go ahead. In star p, there is another variable p initialized to null. I will not show anything, blank is null here. P is equal to address of x. Let me take the address of x something. Suppose it is 700. So 700 is stored here, means this is pointing to the variable x. Next statement. Value at p. What is a star here? Dereference operator. How to read this statement? Value at p is equal to 10. So you can just say value at, what is the p? P is 700. So you can rewrite this statement like this, is equal to 10. And now execute that. Value at 700. Value at 700, I am going to modify to 10. Alright. Next. P is equal to address of z of first element. Z is an array, isn't it? And z1 is the first element of the array. This is the first, this is the 0th element, and this is the first element as per the index. Now this is the z1. What is its address? 502. And where we are storing it? In the p variable. So because there is a AND operator here, address of this element. Address of this element is how much? This is z1 and this is z0, isn't it? So 502 I am going to overwrite here, alright. So this will become 502. So now this will point to this element, alright. Let's go ahead. Again a dereference operator, alright. Let's see what is this address. Whenever there is a dereference operator, it needs an address in front of it. You see, value at some address. So this statement, compound assignment, here it is. So value at some address is equal to that value plus 3. Alright. So what is this address? Address of Z0. What is address of Z0? That is 500. I will rewrite this statement. Value at address of 0th element. Address of 0th element is 500 plus 1 is equal to I'll just rewrite, I'll just expand it. Alright. Value at, again the same one, 500 plus 1 plus 3. Plus is equal to 3 means this expression plus 3. Alright. Now let's simplify this. 500 and plus 1. See, 500 is the address of an integer, isn't it? 500 is an address of an integer. Therefore, if you add plus 1 to it, it will become 502. So this expression is nothing but 502. This expression is nothing but 502. Same. Let's calculate. Is equal to. So value at 502 is equal to, what is the value at 502? 11 plus 3 is equal to 14, right? And it is stored at the address 502, back to the 502. So it will become 14. Alright. Now, next statement is printf. What we are printing here? %d, %d, %d. All integers we are printing. X is how much? 10. Z0 means first element is, first means the 0th element is also 10, and Z1 is 40. Alright. So 10 is printed instead of this first format specifier, 10 and 40. Pretty simple example, straightforward. So 10, 10, 14 is our answer here. So option D is the correct answer. Let us see the other example numerical that was asked, other program. What is printed by the following ANSI C program? Here in this program, I can see that there is a 3-dimensional array declared, and the values are assigned or initialized like this. How many I, j and k? You see, if I have 2-dimensional array, let's assume, we call it as a rows, number of rows and number of columns. But here 3 dimensions. So this I can call it as a plane, first plane, 3 rows, and each row has 3 columns. So we have 3 planes, each plane has 3 rows and each row has 3 columns. Total, how many elements we have? Total elements in all the planes we have 3 into 3 into 3, that is 27. Alright. I'll draw it in the memory representation. Alright. These all values we will show it. Let me read the program first. Int I is equal to 0, j is equal to 0, k is equal to 0, and for loop. I varies from 0 to 2, I plus plus. K varies from 0 to 2 again, k plus plus. And this statement belongs to the for loop only, the inner for loop, this printf. I, j, k. So we are just printing the values here, and this printf statement belongs to this for loop because there is no bracket here. So this for loop is just one statement here. Alright. uh, the outer for loop is just printing the next line, alright, and return 0. So let's see what is printed. Let's see what options are given first. You see, line 1, next line 2, next line, and 3 values again. So let's simply execute the program and try to get our answer. Now see, whether it is a 2-dimensional array or 3-dimensional array, memory is always 1-dimensional, right? So how many planes we have here? 3 planes. Means these 27 elements are divided into 3 because 333, right? I, J, K, 333. I'll write I. This is plane number. J. This is row number in the plane. And K is the column number. Alright. So first we will and all these 27 elements will be arranged plane wise. First plane, second plane, and third plane. So let me divide this entire memory for 27 elements in a contiguous manner, 0 to whatever. So in 3 parts. So I am just going to divide it in 3 parts. This is I value 0, that is plane number 0. This is I value 1, and this is I value 2, plane number. Alright. Now in this you can take each plane has a 2D array. So can I say the 3D array is a collection of 2D arrays? And in this collection, how many 2D arrays we have? 3. First 2D array, second 2D array, and third 2D array. Alright, let me go back to the question and see. Alright. Now see, here the first plane has been assigned all these values. So that will go into the first plane. That all values will go into the second plane and the third plane. Alright. Total 9 values. 9, 9 and 9. Why? Because in one plane we have 3 rows and 3 columns. 3 rows and 3 columns, right? So if I again bifurcate this memory into 3 rows, let me just bifurcate into 3 rows now. This is row number 1, 2 and 3. I mean here it is j is equal to 0, row number 0 in the plane number 0. Next, j is equal to 1 and j is equal to 2. I, j, right? And in each row we have how many values? We have 3 values, 3 columns, alright? So let me show it by other color. 3 values, 3 values and 3 values. Total 9 values. Let's put the numbers. So what is given in the first plane? 1, 2, 3 up to 9, 10 to 18, 19 to 27. Straight away 1 to 27 numbers are given. So let me put the numbers now. Alright. 1, 2, 3, 4, 6, 7, 8, 9. Alright. So this is row number 0, row number 1, row number 2. And here it is k, I, j, k, isn't it? Here it is k0, 1, 2, 0, 1, 2, 0, 1, 2. Alright. So that represents k. K varies from 0 to 2. Here k varies from 0 to 0 to 2. Alright. So in each array we have 3 elements. Likewise all the other planes also likewise. So what about the second plane? We have it is divided into 3 parts. It is divided into 3 parts. Alright. Let's put the numbers here. it is j is equal to again 0. You see it is a boundary here, right? Here it is j is equal to 1 and j is equal to 2. J is equal to 0, j is equal to 1 and j is equal to 2. Let's put the values. I'll not just show, I'll just write all the numbers now: 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, all these are the numbers. Of course, there is a division. In each array. Alright, let's now check what is the printf statement. Okay, so the printf, the for loop, outer for loop, I, here it is I, j and k, right? I, j and k. So we are looping from all the planes. So from all the planes we will go. For all the planes, j loop is not there. J value is 0 for all these loop iterations. Alright. So the j is, for all the printf statements, j is going to be 0. J is going to be 0, isn't it? And what about k? But k is varying. K plus plus, isn't it? K plus plus. So for each I value, k will be 0 to 2, k will be 0 to 2, k will be 0 to 2. So here this is plain number, this is plain number, this is row number and this is column number, isn't it? So row number is constant here for entire iteration. That's why if it is j is equal to 0, means for all the planes, let me put the values now: 0, 0, 0 and 0. What value will be printed? Okay, 0, 0 and 0. I, j and k, 1 will be printed. Next is 0 again, 0, j is 0 and k is 1. 0, 0, 1. 0, 0, 1. 0, 1, 2, isn't it? So 2 will be printed and of course 3 will be printed. K plus plus again. Next, in the next inner loop, k value will be 1 now. Alright, I'm sorry, I value is 0, now I plus plus. This is done. 3 times it is done. 3 values are printed. Next, I value 1, 1, 0 constant, 1, 0, k varies from 0 to 2, right? So here 1, 0, j value is constant. So that means only first row we are going to print here. First row and first row of all the planes. That is our answer, isn't it? So what is our answer? 1, 1, 1, 1, 2, 3, first row. Here in this plane, what is the first row? 10, 11, 12. And here what is the first row? 19, 20 and 21. That's it. What option it matches? Option number A, 1, 2, 3, 10, 11, 12, 19, 20 and 21. Alright. Let's see the third question that have been asked in the GATE 2022 for 2 marks. What is printed by the following ANSI C program? Main function character A, let me just draw and show it in the memory. Character A, the char A, we know that character is of 1 byte, isn't it? Means how many bits? 8 bits. Capital character P is stored in this variable A. Now we know that how the characters are represented in memory by their ASCII values. Fortunately, in this question, all the ASCII values are given. Alright, but even if it is not given, you should know capital A is 65 and the rest of you can follow up to Z. Small a is 97, rest thing you can follow. You may not remember this, but in this question it is given. Star character, plus character and minus character have these ASCII values. So when it comes to the memory, the ASCII value is stored. Now tell me, what is the ASCII value of capital P? If I look at this table, if I just count 65, 66, 67, A, B, C, D, E, F, G, you can just count. The ASCII value of capital T, capital P will come as 80. You have to just count from capital A, that is 65 onwards. Alright. Next, there is another character B, small x. What is the ASCII value given? Starting from 97 onwards, x, y and z, right? So if z is 122, y will be 121 and x will be 120. Alright. So let me write here 120. 1 byte, 1 byte, 1 byte. Characters C, D and E, there are 3 characters whose values are calculated using these expressions. And there is a printf statement %C, %C and %C. So of course characters are going to be printed. Alright, numbers are not going to be printed. What are the options given? Let's see. Okay, the given options are, out of which this is a number 122, 75 and 83. So of course this is not our answer, because %C, %C, %C it is given. And if you observe carefully, you don't have to solve the entire question, entire program. First character is small z, first character is star, first character is capital P, capital P. If it is so, you just need to find out what is the first character printed, because all the options are different. Alright. So just first printf statement you can answer and your answer is here. Alright. Let's go back. So first %C, %C is character C and this is the expression for character C. Alright. So let's take the character C now. What is the expression? A bitwise and B, A bitwise and B plus character star, character star ASCII value, because it is a character given, alright. So let's first do A. What is the A? 80. Bitwise and, so we have to write the binary pattern of 80, right? What is the binary pattern of 80? 80's binary pattern, let's calculate A and B first. So what is the binary pattern of A, that is 80? It is 0, 0, 0, 0, 80 is nothing but 64 plus 16. 64 plus 16, isn't it? So it is 0, 1, 2, 3, 4, 5, 6. 2 raised to power 6 is 64. 2 raised to power 4 is 16. 64 plus 16 is 80. But how many bits to consider? One byte only. 1, 2, 3, 4, 5, 6, 7 and 8. That is your 80. Only one byte. Next, 120. So if you convert 120, it will be 0, 0, 0. You have to be good in converting the decimal to binary pattern. I am not going to explain everything here, but yes, you can take your time and just convert 120 to the binary pattern. Alright. Now, let us do the AND here. What it will be? 0, 0, 0, 0, 1, 0, 1 and 0. Alright. So, what it comes to the value? So, it comes to, let me just verify once again, 1 and 1, correct. So, is it not equal to the same one? Isn't it? The same one. Alright. So, what will happen? This in binary is 80 only, isn't it? Is 80 only. Means this expression is 80. Alright. What about star? What is the ASCII value of star? Let's see. Star is 42, right? So it will be 42, right? So what will be our result here? 80 plus 42. 80 plus 42, that will be 122, and 122 is stored in the C. Alright. So we got the first value of C, I mean the character C's value, and character C's value is printed first, right? CDE, CDE, percent %C. It is printed, we are giving the number, character as a value, as a decimal value, but here it is a percent %C. That's why equivalent character will be printed. What is the equivalent character of 122 ASCII value? Let's see the table. It is Z, right? So our answer is option A straight away. You don't have to solve the entire question I am saying, right? But we will complete the question. Let's see what is printed. All right. Until now, up till now, it's all clear. Fine. Let me just erase it because I don't need A and B onwards. It is different logical operators. So A, I'll just erase this one part. All right. Okay. Now, character D is equal to A or B. Let us do the OR here. 0, 0, 0, 1, 1, 1, 1, 0. Is it not same as this number? What is this? 120. This is 80, B is 120. This is A and this is B. So, the outcome bitwise OR is 120 only. And so this expression is 120, isn't it? Alright. This expression is 120 minus, what is the minus ASCII value? 45. What is the expression result? Minus 45. So it is going to be 75. 75. Let me just correct it. All right, 75. All right. So 75 is going to be stored in the D variable, right? And when I print the D as the character, what is the equivalent? What is the equivalent character of 75? So if you just count A, B, C, D, E, F, G, H, I, J, K, right? So 65 plus, it is 65 is a capital A, isn't it? So if I just count, it will be, I think, capital K. Let us look at the option. Yes, capital K. All right. Or you can just count from here. Okay. So we have got the second one. Now the third one. Third one is what? Bitwise XOR. What is bitwise XOR? Let me just rewrite this. 0, 1, 0, 1, 0, 0, 0, 0. This is A. What is B? 120. I am just rewriting this. 0, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0. XOR. Let us do the XOR. Okay. When the bits are different, when the bits are different, it is going to be 0, 0, 0, 1, 0, right? Bits are different, 1, 0 and 0. Okay. All right. And what is the binary equivalent? 0, 1, 2, 0, 1, 2, 3. 2 raised to power 3, 0, 1, 2, 3, 4, 5. 2 raised to power 5. That is 32 plus 8, 40. Okay. So first expression is 40. Let me just write here. So this expression, what it will become? 40 plus. Plus is what? 43. Plus 43. It will be how much? Character E will have the ASCII value 83. Now if you count, and we are just printing in the character. So what is the equivalent of 83? If you just count 83, it will be capital S. Alright. So this is how we solve this question. Thank you.